to the presentation on implementing clean architecture with Kotlin. I was going to walk around a bit for this talk, but unfortunately, someone said to me, "Hey, break a leg," and I took it a bit too seriously, and I ended up in a cast for a couple of months. So, what's the agenda today? Well, first I'm going to give a bit of an introduction on what clean architecture actually is. Then I'm going to give a demo. I'm going to implement the clean architecture completely from scratch. And then I'm going to do a quick recap on what you actually need to think about when you're doing clean architecture and what the differences are with the normal one. So, who am I? I'm a Java engineer at ACIT Solutions, a company in Belgium. And mainly I'm an open source fanboy, which means if it's open source, I love it. Mainly I do backend development, which is from REST services to the database. And above all, I'm a software craftsman, which means technology is great, but I mainly look at how software is designed and how it should be written and how cleanly it's written. And I have a blog on which I write a lot of articles, some relating to software craftsmanship, clean architecture, or just plain technical stuff in general. So what the bleep is clean architecture? Who actually knows or heard about clean architecture? Yeah, quite a few. Okay, great. It's actually a compilation of architectural styles. So you've got hexagonal architecture, which is the ports and adapters. Then you've got the onion architecture, which is the layered architecture, which most of you know about. You've got the screaming architecture, which is a coin pitched by, for example, Robert C. Martin, or known as Uncle Bob, to have your architecture scream intent and not just the technological pieces of your application. So it should communicate the business value and not just the technical parts of your application. You also have DCI, which is data context interaction, and BCE. The name just skipped my mind. But those are actually older parts that are coined since the 80s. So the term clean architecture actually was coined by Robert C. Martin, also known as Uncle Bob, in a 2012 article. And he actually showed this drawing. This is the basic onion architecture that most of you use. You've got your outside onion layer, which is your consumer side. Then you've got the green layer, which are your controllers, your REST controllers, your presenters, or your gateways to your system. Then you've got your use cases, which is mainly your services. And then you've got your entities, and you're basically your domain. When you extend that to a hexagonal architecture with your ports and adapters, you're going to have your different ports, or your REST layer, your infrastructure layer, or, for example, when you want to expose your stuff to GMS. They always communicate through an application API, which is implemented by your application, which then communicates to your domain and goes to your producing side. For example, REST clients, when you want to get data from external systems, your Postgres, Hazelcast, whatever. So your flow of control is always from you go to REST layer, to your application API, to your application domain, and then your persistence layer. But, for example, with the dependency inversion, you can make sure that your calls never actually see where they are being persisted, or even whether there's an actual domain underneath, or just you go directly from your application API to your persistence. Don't do that, by the way. So when you look at the components in a clean architecture, this is actually the drawing from Uncle Bob that I adapted a little bit. You've got your use cases. Those are actually the gravity of your application. It screams intent of what your system is supposed to do. So for example, you're going to have create something, get something. Those are the intents of your application. Then you're going to have your use case implementations. And the use cases will always have a response model, not always, for example, if it's fire forget, and optionally a request model. The implementation will use an entity gateway, which actually will be implemented then by your persistence layer to save or get data from your system. And the entities, those are your domain entities. From the consuming side, you're going to have your basic REST controllers or something else, your JMS producers. They are going to consume the response model through a response model consumer, which will be implemented by a presenter to make sure that your domain model doesn't leak into your controllers so that you can easily change things around. But being pragmatic is key. You're saying, okay, but I have to build a lot of data structures to map between all those. That's true. And you can omit some, but you have to realize that every compromise that you introduce in such a system is a technical debt. And at some point, that debt can be collected. So let's start coding and build a clean architecture in Kotlin. Why Kotlin? Well, it's a very nice language to work with, and it's getting a lot of traction nowadays. For example, Spring is going all out with Kotlin, and for example, in the Android ecosystem, Kotlin is very popular because of the fact that they can use lambdas, while as Android is still on Java 7. So actually, I have a basic Spring application, a Spring Boot application. I'm using Spring Boot just as an example. You can just as well use this in a Java EE environment, Wildfly, Vertex, whatever you want. So I have a plain, simple Spring Boot application that doesn't do anything yet. Our use case is going to be, we're going to build a PMS system, a property management system. So our first use case is going to be, I want to create a building. Okay, so I have two data structures. I have my request model and I have my response model. So I'm going to make a data class, create building request. It's going to have one field, which is the name of the building. And that's it. Data class in Kotlin is something that is purely designed to hold data structures. It implements some nice stuff like the equals and the hash code. And the vol is like, for the people that know Scala, it's the mutability designation that it's an immutable property. And then I'm going to make the response. And it's just going to return the ID of the building that's been created. Then I'm going to make my use case. My use case is just an interface on which I'm going to clarify intent on what my system is supposed to do. So my interface is going to be create building. It has a single method. I'm using here single method classes. Why? Because then I can use lambdas if I want to. But for example, you can also use different methods in a single class. A use case is just a single method that's clarifying the intent of your system. So I'm going to make a function which has a request as a parameter, and it returns the response. Okay, now you can choose whether you want to go up or go down. Do you want to provide a consumer side, for example, your REST controller, or do you want to immediately go and implement that to your domain and to your persistence layer? Now, for the sake of the demo, I'm going to go up, and I'm going to implement a controller. So I'm going to make a basic controller, a building controller. It's a REST controller. And I'm going to make a single method, which is create. It's going to get a payload, which will contain the name. And like I said, you don't want to expose requests from your application layer directly into your REST layer. You can do that, but then again, you are introducing technical debt. If you want to change your request, then you need to be aware that you're also changing the contract of your REST API. So I'm going to have a payload. Which is a building JSON. Oh, that's not great. And of course, it doesn't know the building JSON yet, so I'm going to make a new data class. And then, of course, I need my use case to use in this controller. So I'm going to inject this. Into my controller. And now I can basically make a call to my use case. And I have to create a new request. You can just do new building, new create building request here, or you can add a method to your building JSON that's responsible for making a creation request from the JSON. That choice is completely up to you. I'm just going to make it in here. Right, Kotlin does not have the new keyword. And I'm going to have my building dot name. This is going to be a post. And I want to return something. For example, I just want to return a string, which is the ID. I have to tell it that it's a response body, otherwise it's going to interpret it as a view. And I'm just going to return the ID. Of course, when I try to run this now, it's going to complain that it doesn't have an implementation of the create building yet. So let's just make a standard implementation, a mock implementation of our create building request. So I'm going to make a mock create building, which implements create building. And I'm just going to make it return hello. Of course, I need to put this in the response. And make this a component. Why do I use named here? Because this is something that you're going to use in your application layer. Your application layer should be devoid of any application, any dependencies on frameworks. So ideally, you don't want to use Spring in your application layer or your domain layer. Those are reserved for your infrastructure layers on the outside of your onion. So now I'm going to run this. There we go. And I'm going to increase my font a bit. And I'm going to do a post. I'm going to tell that my body is JSON, and I'm going to post to my body is name is multi-kino, which is where we are. There we go. It just prints out hello, which is our mock implementation of our system. Now I want to really implement that into a real implementation. So I'm going to remove the mock. And I want to use a basic domain. So I'm going to implement my domain, which is a class, a building, which has a name and an ID. I also need an entity gateway, which is the way that the domain says, okay, this is how I can persist my system. At the moment, I only need one method, which is I need to persist a building. And I return the ID. Actually, I don't need that. So now, if I want to do something with I want to make a real implementation, I'm going to make my create building impl. Which extends from create building. And it needs an entity gateway. As you have seen, my domain also requires an ID. In domain-driven design, you're normally going to use a factory to make your domain objects. Now I'm just going to make the ID here myself. Just going to make a random UID. I'm going to make my building, my domain object, based on the ID and the name I got from my request. And I'm going to call my building gateway. All right. And I'm going to persist my building. And of course, I also need to return a response, which in this case is just the ID I just created. So now we have a complete real implementation of our use case. Of course, it won't work because we don't have a gateway just yet. So I'm going to make my infrastructure layer for my persistence. In this case, I don't want to choose yet whether I want to use JPA or I want to use Mongo or want to use Neo4j or any other cool persistence technology that currently exists. So I'm just going to make a map implementation, which is, for the moment, more than sufficient. So this is just a map gateway. I want to persist, and as a field is just going to have a map of string to building. My data store, it's just an in-memory data store, in other words. And in Kotlin, you have to know whether a map is mutable or not. By default, all maps and all collections that you know of, the normal names, map, list, set, are by default immutable. So I have to make another type. They have another type called mutable map. And I'm going to initiate. What am I missing here? Yeah, right. Oh, great. Thanks. That's for seeing too much Java today. Okay, great. Thanks. So I'm going to have my data store doesn't even have to be immutable. And the one thing that I'm going to do is, okay, data store dot put my building dot ID building. There we go. Just love mob programming. Again, here I'm in my infrastructure layer. I can make choices to use Spring or something else here, but I tend to use Java Xinject. Spring works with it, and it's a standard, so it's great to work with it. So now I'm going to run my application again. Of course, this one needs to be named as well. Don't you just love the error messages in Spring Boot that it just says what's wrong? So once again, I'm going to do something, and now it returns the ID I just created. Okay, great. But now I only have a system that can persist stuff, and I don't even know whether it's really in there. I just know that it gives the ID. So let's make a second implementation, a second use case, which in this case is just get me all the building names. So it doesn't really have a request, it just gets all of them. And I'm just going to make a response in this case. So get building name response. And what will it contain? Well, the names, which is a list of string. In this case, I can clearly use list because I don't want people to mess around with the data structure that my use case is returning. And I'm going to make my use case. Doesn't have a request, just a response. Then, of course, I need to make a second method in my controller to expose that new use case. Does not have a body, but it does return a list of string. Of course, I need to inject my new use case and tell it, okay, now you can return the get buildings names dot list and the names inside of it. Now I have to implement that use case in my application layer. So I'm going to have get building names impl. Once again, I'm going to use my building entity gateway because I want to access my domain. And it's just going to access the building gateway, and it's going to get my building names. Doesn't exist yet, so let's make it. Okay, now I have a new method, get building names, that returns a list of string. And I also have to implement this in my data store. So data store values map there we go. That's it. It's going to fail because I didn't put this one. Okay, so I can post some stuff, and I can also get the data back from my system. Okay, great. Now, most of you think, okay, this is all great, but this doesn't really show me some added value. Well, now I can just plug in another implementation into my persistence layer without having any other layer being affected. So I actually don't need to do anything on the controller side or my implementation side. For example, I want to put MongoDB underneath my system to handle the persistence. Okay, great. So I'm going to I have MongoDB from Spring Data as a dependency on my system. So I'm going to make a single basic class, a Mongo building, which has an ID and a name. Forgot the name. I have to say this is the ID. And I'm going to make a simple Mongo repository to persist my my Mongo buildings. So it's going to be a Mongo building, and it's persisted. My ID is a string. Doesn't have to be an interface, of course. And now I have to implement my gateway once again, but using Mongo this time. So I'm going to make a Mongo gateway. And I'm going to inject my building repository. And I have to implement those two methods. So now at this point, I can say building repository. Forgot the val again. And I'm going to say save new Mongo building. Of course. Damn you, Java. Building.id, building.name. Okay, I've got the save covered. And I also want to use the get from my building names. So building repository, find all, .map, it.name, .toList. Now, one of the fun parts of Kotlin is because those are one line methods, I can just as easily say this. I don't need a return value then. Okay, so now I have to put this as named. And if the demagogues are kind, this will work. Could be that there is still some old data in my system, but okay, great. So now I'm going to do the post again, multi-kino. And if I now do the get, there was some old data in my system, but as you can see, multi-kino has been saved. If you don't believe me, I'll do it again. And then there it is. So now I've just implemented a new persistent layer without having any impact on my system. One of the fun parts that you can do with Kotlin, now I'm doing everything in the same source file, but normally there's a reason why I put the comments in between each and every part of the file. Those normally are going to be in separate modules. So that also means that your controllers will only be able to access your application API. The application API will implement that. The application will implement that API, and the application can reach the domain, which is then implemented by one of your infrastructure layers for your persistence. In that case, it's very interesting to know that now I'm doing here Mongo building, I'm making a new one, and I actually am using I'm telling something what to do, and I'm not asking my model to get itself into a Mongo representation. Problem is, my domain does not know about the fact that it's being persisted by a Mongo. With Kotlin, you can do that. You can make extension methods. So for example, if I make a new function on my building, I'm saying, okay, I have a new method to Mongo, and I'm returning this. Of course, building it does know, but this actually implies the instance of the class that actually the method is being called on. And now I can say building to Mongo. So now I've actually extended my domain model to implement certain features that are only accessible from my persistence layer. If I try to access this from any other layer that doesn't have the direct dependency of that infrastructure layer, that method won't be available to that module. So that's about what clean architecture is about. It's defining clear boundaries of your system and being able to immediately change certain aspects of your application so that you can play around or try new approaches on your system. So let's do a quick recap. The application and the domain should be devoid of frameworks. Why? Because then you're tying yourself to a certain choice. You want to be able to just move your domain or your application layer to other platforms. I can easily make a new deployment and make it work on Java EE or Vertex, and I don't normally have to change anything on my application or domain layer. So your application and your domain should only contain business logic and application logic. It should not contain anything about persistence or how it's being exposed to the outside world. Technological choices are made on an infrastructure level. That means you're going to make it on the outside layer of your onion, which means you can choose whether you want to use Spring MVC, you want to use JOXRS, Vertex to expose your systems. And on the other hand, on the inside world, you want to make sure that you want to switch between, I want to get it from a database, from a MongoDB, from an in-memory map presentation, or from an external system through JMS or a REST client. And the main partition, which is this little thing, this is actually what binds your application together. This is just makes it runnable. If you want to use Spring Boot, this is the way you want to do it. With Wildfly Swarm, you can also make a main method that wires everything together using their dependency injection system. But it gives you the choice and to defer certain choices to a later stage where they actually make sense. This is actually the main concept between clean architecture, is to defer technological choices to a time as late as possible in your system. This makes it very easy for you to switch between certain implementations. So I think I went a bit quicker than I thought, but are there any questions?
How about testing?
Well, testing, that's a very nice question. What you can do is, well, you can mock your application layer or your infrastructure layers, which you can do, or you can make mock implementations from both layers to make sure that those are being tested in isolation. So you can mock every layer of your system without having to worry about the fact that it's using some other part of the system that's not being mocked. So this approach actually makes testing a lot easier because you can mock each and every layer in your system and each and every module in your system. Yes? Oh.
So you said something about clean architecture being a combination of different architectures like onion, hexagonal.
Yes.
And there was also DCI. I'm curious, what connection do you see between DCI and clean architecture?
Well, data context interaction actually puts the emphasis on clarifying business intent in your system. It actually shows what your system is supposed to do. So that actually implies, this is actually more the use cases that your system tells the outside world what it's capable of doing from a business concept. So the data and the context and the interaction is purely on a business level. It does not show whether it's being persisted to something. It just clarifies the actions that your system is supposed to do from a business and a domain standpoint. So normally your business people should be able to look at all the use cases in your system and tell what they are supposed to do.
Okay, but this is like the fact that you want to focus on the business. It's like just a general theme. And when you go to clean architecture, you have these interactor or use case classes.
Correct.
Which contain like most of the implementation of the use case, like the orchestration of logic between the objects.
That's actually a choice that you can make. For example, if you want to do orchestration inside of your use case implementations, that's a choice that you can make. But for example, if you're using domain-driven design, you're going to have that behavior being transposed on your domain and not do the orchestration inside of your use cases, but rather have your repositories, your entity gateways, return domain objects, and call business behavior on that domain.
To some extent, yes. Nevertheless, like in DCI, you have these object roles and contexts, and these are actually supposed for carrying out the use case for yourself. So this is clearly defined there. And like there's, I think, no direct translation between the entities and use cases and between context and roles in DCI, or is there any?
I actually don't have an answer on that one, sorry.
Okay.
Any other questions? No? Okay, so thank you for listening. The Java example for clean architecture, which actually does the module split up on a code level, where you cannot use certain parts of the system, is available on GitHub. I'm going to make the Kotlin example available pretty soon, which also will use the modules so that you can use the extension methods and see that certain methods are only available to the outside world depending on which dependencies you have. So thanks for listening. If you want to contact me, I'm still here till Sunday, but you can always ping me on Twitter. And thanks to GeeCON and ACA for letting me do this talk here. Thank you.